Hello everyone, today we will learn the concept of integral convergence and the use of U substitution. When we determine if an integral converges or not, we will first see its result. When its result is a real number, then this integral converges. Otherwise, which means this integral doesn't have a result, or its result is not a real number, then this integral diverges. I will use two examples to show this idea, and I will use U substitution in it. First, let's see this integral. This integral doesn't look quite familiar for us, because it has the square root of 1 minus x as its denominator. So how could we integrate it? First, we should find a function u in terms of x. In this one, I choose 1 minus x equals to u, which means du equals to -1 times dx. Second, we should replace all the x, upper boundary, and the lower boundary in the original integral with u. Since u equals to 1 minus x, x equals to 1 minus u. And for x equals to 1 as the upper boundary, u equals to 0. And for lower boundary, when x equals to 0, u equals to 1. And replace all this stuff into the original integral, we can get a new integral, which is 0, 1 minus u over the square root of u times du. But we should especially pay attention to this du part because it equals to -1 times dx. But we don't have -1 in the original integral, so I have to keep the old one and this new one the same. I should add a negative in front of this new integral. Then we can begin integrating. This equals to u to the -half minus u to the +half times du, and this equals to -2 times u to the +half times 2 over 3 times u to the 3 over 2, and with the boundaries 0 and 1, we can get the result is 4 over 3. Since 4 over 3 is a real number, we can get the result that this integral is convergent. Okay, let's see the next example. For this integral, we can follow the same steps we did for the first one. At first, we should find a function u in terms of x. For this one, I choose u equals to x squared, which means du equals to 2 times x times dx. And then replace all the u upper boundary and the lower boundary with u. But luckily for this one, as x goes to positive infinity, u also goes to positive infinity. And when x equals to 0, u also equals to 0. So it has the same boundary with the original one. And sine u times du. You may possibly say that I missed an x here, but I don't miss that because du equals to 2x times dx. This x appeared in the original one, but this 2 doesn't appear, so we have to add an half in front of this new integral. Then we can begin integrating. The result is half times negative cosine u times du. Then we can get make a graph of this cosine u. which is just a brief graph like this. As u goes to positive infinity, we can see that the area is bounded by cosine u, and the axis also goes to positive and also goes to infinity. So how could we decide the result of this? We cannot get the result of this, so this integral just diverges. I hope you can get the idea of the integral convergence and the use of u substitution from these two examples. Thank you for watching.